the POPAID route of producing TOPCon for utility applications. The presentation is given by Jiayu. Hope I pronounce your name correctly. And Ma is a product manager at Jolywood, and probably you all know Jolywood has recently announced their TOPCon 3.0 technology. I think Ma would give us some more insights into that. So the floor is yours, Ma.
Sure, thank you. And let me just share my slides. Yeah. So happy to meet everyone at TaiyangNews Conference. So today I will represent Jolywood Solar to introduce our new TOPCon technologies. And my topic today will be the POPAID rotates for producing TOPCon for utility applications. So it will be including 3 parts. So the first part will introduce Jolywood as a company, and then we'll introduce Jolywood J-TOPCon technologies. Then I will give you a project reference to show the benefit for the utility projects. So let me just start. So Jolywood Solar, we are established in 2016, and we started doing the N-type product at the same years. So actually, we are the first company in China to doing the mass productions. And up to now, so Jolywood is listed in the Tier 1 Bloomberg, and we have been awarded as the national high-tech companies, and we also the national green factories. And as a company who are contribute to the green energy, we have also care about the environmental friendly. So we also have the PV cycle membership in Italian, and we have the carbon footprint in French. And as the leader of N-type bifacial solar cells technologies, we have a very strong R&D teams. So we have more than 300 R&D members and more than 200 applied patents. And just last month, our large size cells has achieved the new what we call 26.1% in efficiency in the lab. And up to now, we have the module capacity of 3.5 gigawatt in Taizhou. So this picture here is actually our factory in Taizhou. And also we have cells capacity of 7.6 gigawatt, which including 3.6 gigawatt in Taizhou and 4 gigawatt in Shanxi. And we still have 12 gigawatt on the construction and will be finished by the end of 2023. And also, as the first company in China to do the mass production, we are the only N-type module supplier for the UMPD, the Panda Power Station. And we have been shipped over 5.8% product to over 16 countries. And we have taken over 10% market share in the Middle East, including some famous project like the 500 megawatt project we have in Amman, which is the world's largest N-type power station. And also the 2022 is a big year for N-type technology. I can see more and more companies are shifting their production line from P-type to N-type. But Jolywood upgrades the P-PERC to N-TOPCon very earlier since 2090s. And we choose TOPCon, which is then for the terminal oxide positive contents, as its very early stage due to it has the highest theoretical efficiency, which is 28.7% for single crystalline silicon cells. And due to it has benefits on the performance and the reliabilities, which can give you a good LCOE and also reduce the payback time, which I will give you more details later. And I think the polysilicon layer is the key structure of the N-type cells. So we will spend more time to investigate the different process of the polysilicon depositions. So this table here actually is summarize the most common technology for the deposition right now. So we have the LP-CVD, PE-CVD, AP-CVD, PVD or POPAID and evaporations. So the LPCVD, which is already well proved in the market right now, it has been demonstrated in the lab size and also widely used for the mass production. But the main key defect we found is it will have the wrap around. And per the PECVD, also it has the demonstrate in the lab size cells, and it has the possible to doing the single size depositions. But although we already have the industrial tool, it's not widely used in the industry cells production right now. And then also we come to the third column about the PVD, our POPAID. So POPAID is actually self-developed by Jolywood. So it is one of the best technology right now for the single size deposition. And we have also the demonstrate in the lab size cells, but Jolywood is the only and the first company to use this technology in the mass production. And for other technology like the APCVD or the evaporation, we may don't have too much details. So I will move to next part. So different deposition methods will come out with the different cells precision. And here the flow chart will introduce what is the process for making for Jolywood TOPCon solar cells processings. And for the LPCVD, without the instant dopings, it will cause the polyweb around. So you need to have the attentional process to remove this polysilicon web around, which is difficult. So because it is difficult to control, and maybe will cause some negative impacts on the cell's efficiency. And also we have the PECVD, which they have much less web around, but still need to have the polyweb around removal process, but it's easier to control compared with the LPCVDs. And then we come to the POPAID. So due to the POPAID, it uses a different process, so it will not have any polyweb around, but we still need to doing a cleaning by using the hydrofluoric acid. Next step. So as we mentioned, so we already applied this POPAID in our mass productions. And all of our mass production right now is using this technology we call J-TOPCon technology 2.0. So POPAID is then for the plasma oxidide and plasma assist insitu-doping depositions. It is the first time this technology used for the N-type products in mass production. And Jolywood is the only company to apply these technologies into the large scales. And the POPAID is an insitu-doping process. So the terminal oxidide is more uniform compared with the standard process. So if we look at the picture here, we only have the polysilicons from one side. And besides, it is easier to control the doping with the high deposition rates, which means we can have higher efficiency and higher yield. So according to the data from our factory, the max production for our TOPCon 2.0 modules will reach more than 24.8%. And also we will discuss the yield advantage of the POPAID technologies. So since it has no silicon web around, so the electrical linkage will reduce from more than 0.5% to less than 0.01%. and the polysilicon web will reduce from 0.4% to less than 0.01%. If we look at the yield here, so the cells by using LPCVD will have a significantly back age, but the cells using POPAID technologies have much less back age. So the number is actually reduced from more than 1.1% to less than 0.1%. So then what is our next step to further improve our efficiency? So our team will doing optimize on the cells structure. So on the front contents, we will optimize the FE technologies and optimize the finger patterns to reduce the shuttering loss, and optimize the ARC to reduce the shuttering loss. And at the back contents, we will optimize the polysilicon crystallinity and the thickness to further improve the efficiency. And just a new record from our lab last month. So the Jolywood cells efficiency has reached the record of 26.1% in the R&D lab based on the 182 millimeter wave certificate by the NIMC, so which is a new achievement by our R&D team. And then we combine our POPAID technology with the large cells wave, which I'll come to our Jolywood's J-TOPCon 2.0 modules. So those modules, if you using the 182 millimeter wave and with the 72 half-cut cells configurations, it can give you the power more than 570 volts. And if you use the 54 cells half-cut configuration, it will give you the power of 430 volts. And also we have adopted the SMBB technologies. So it will be 16 bus bars. And also it has the advantage of low degradations, high reliability, low temperatures, which overall give you a high efficiency modules and also reduce the BOS cost. And here just a comparison of Jolywood N-TOPCon HD 144 M-type modules, which the normal P-type modules. So as we can see, the maximum module efficiency is actually increased from 21.23% to 22.28%. So the maximum power output will consequently increase from 550 volts to 570 volts. And also it has the benefits for the beneficiabilities and the temperature coefficients, which increase from 70% to 80% and from -0.35 to -0.30. And also, due to the N-type don't have LID and LETIDs, the first year degradations decrease from 2.5% to 1%, and annually degradation decrease from 0.5% to 0.4%. Which we will use those two tabs to doing a comparison of the BOS cost. So under the same configuration, N-type modules usually has 20 volts more power than P-type modules. So if we use those modules for a 100 megawatts power station, it actually significantly reduces the modules you used. So the number comparison is here. And consequently, it will reduce the cost of the foundation, the brackets, the cables. And also there is a calculation based on auto project data in Hunan province. So we're doing the system BOS calculations. So we can see that in the market right now, the module price of PERC is more cheaper than TOPCons, but the generation hours TOPCon will have longer generation hour than PERC. And consequently, we reduce the installation costs, the breakage, the foundation, the cable, or other fixing parts, as we mentioned in the last slides. And totally, the BOS cost will be actually reduced by 2.4%. And also, if we doing the economy analyze on the different price difference, so we can see that the PERC has actually 0.1 yuan per watts expensive than the PERC, but the LCOE will still reduce by 4.66%, and the IRR will increase by 8.7%. And if we compare those two types of technology at the same LCOE, the N-TOPCon actually will have 0.21 yuan volts active values. That is why the reason more and more customers choose to use the N-type modules for their power stations. And I think in the future, the cost of the N-type cells will still reduce, and consequently will be the same price as the PERC. And more people will use the N-type technology for their power station over the projects. And here just some case reference. So there is some commercial projects in French and Poland, Finland. And also there is some project case for the utility projects. So those two are on the armaments. One is 125 megawatt and the other is 458 megawatts. And also we have an installation in Germany, which is the vertical installation. The owner chose the Jolywood N-type because of its high beneficial abilities. So that will be end of my presentation today. Thank you for listening.
Okay, thank you very much, Ma. That's really nice. So since you have finished before as you promised, so I would like to ask you one question. You put 2 tick marks for the wraparound for PVD, and there is only one for PCVD. So can you say the difference? So what's really earning PVD the extra mark?
No, actually, it still have a little bit difference between the PECVD and the PVDs. Mm-hmm. So actually, the PVD which we use and we has called them the POPAID, so it actually has no wrap around. But the PECVD it still will have the wrap around, but much less than the LPCVD. So we think the better solution will still be the PVD, the POPAID.
So that means you don't do any sort of processing for the front side in terms of removing poly. So you don't do.
Yes, so we don't do any of the process about remove the polysilicons wrap around. Yeah. Okay, great. I think that's one good news. And the second thing is, you mentioned the J-TOPCon got this record 26.1% efficiency. Yeah. So one question is, what is the mass production efficiencies? So this is kind of probably an R&D cell. So where do you see that cell is implemented in mass production? So where do you see the efficiency? And when you are going to start the mass production for J-TOPCon 3.0? So actually the 28.1% is just recorded by last month. So it's still in the lab size. So I think we will apply this technology to the max production maybe next year. But right now, the technology we use is the J-TOPCon 2.0, which gives you the max production of 24.8%.
All right. Okay. So thank you very much. It's really great presentation.
Thank you.